a quadratic equation to solve. We have to solve 5s squared equals to 7s plus 3. If you look at this type of question, you can ask yourself that, can I solve this one using a factorization method? Of course, the quadratic equation. But if you waste your time solving it using factorization method, we might be wrong, we might be right. So let's establish it. The first thing is that when you have quadratic equations scattered like this, you have to rearrange them to their default appearance. Minus 3 equals 0. So this is the default appearance of any quadratic equation. So the next thing we do is that, having rearranged them, that's the first thing you do. Then we said we want to test if factorization method can be used to solve this question. So what you just have to do is just find the square root of the discriminant, and that's square root of 49. 7 squared is 49 minus 4 AC. In some cases, you might be able to factorize this in some cases, yeah. But in most cases, factorization doesn't work. Minus 3 times 5, that's minus 15. Then we have this to be square root of 49 plus, this is going to be 109. Of course, 109 is not a perfect square. 109 will never give you a perfect square. So with this, you can say that factorization method is advisably should be avoided advisedly. So having established that, we are just trying to establish so that we know that factorization method is limited. So let's go through this question using the completing the square method. So using completing the square method, I'm rewriting the question again. 5s squared minus 7s minus 3 equals to 0. The first step I told you to do is to make sure that the coefficient of this s squared is 1. So by dividing all through by its coefficients. So this is s squared minus 7 over 5, s minus 3 over 5 equals to 0. Implies. So the next thing we do is to take the constant to the other side. S squared minus 7 over 5, x equals to 3 over 5. That's okay? Then the next thing is to find the perfect square from this coefficient. That's minus 7 over 5 times 1 over 2, then square it. Then having done that, you can expand this out by saying minus 7 over 10 square it. We need this minus 7 over 10, which is inside this bracket. Without squaring it, we add it to this side. Then the one that is squared, you add it to this side. This is what I'm saying. This is going to be s. You are not going to be returning this squared to it. Then this minus, you put minus 7 over 10 squared. You are not going to expand it. You just need what you have inside this bracket. Any sign that you have at the front, you add it to this. You are adding. So minus times plus is going to be minus. That's why this is minus. Then it's now equals to, I have ignored this x here. It's now equals to 3 over 5. 3 over 5 plus minus, of course, this is going to be minus 7 squared. Eventually, this one is going to be plus, this is going to be 49 over 100. This square is for this 7, this square is for this 10. Now to find the LCM here, this one is going to be 100, and 5 in 100 is going to be 20. 20 times 3 is going to be 60. Then this is 49 equals to x minus 7 over 10 squared. Then we have 109, 100. So s minus 7 over 10 squared still. So we have to get rid of the squared, that's s minus 7 over 10, then square root of 109. Square root of 109 and square root of 100 is 10. Of course, you can say this is plus and minus so that we have two results. So my s is equals to plus and minus square root of 109 over 10 plus 7 over 10. Of course, it can be s equals to plus square root of 109 over 10 plus 7 over 10 or minus square root of 109 over 10 plus 7 over 10. The plus 7 over 10 remains the same at both sides. It's only this one that shares two signs together. So finally, you can say, find the LCM. This one is 10. This one is square root of 109 plus 7. Or this one is also 10. This one is minus root 109 plus 7. So when you compute this, you will get your answer. But I would like to stop it here because I'm not going to use calculator. So that will be all for the method that is used in solving any form of quadratic equation. So we move on with the last method that we can use, and that's a general formula method, and we also call it the almighty formula. And that one gives us our answer. It's just like summary of this procedure that we're using to solve questions. That's what these mathematicians have tried to come up with. When you have a procedure being carried out repeatedly in the same way, then they form a way to pack that procedure inside what we call formula. And that's what algorithm is also about. When you have a procedure of solving problems by computer, then they pack it together in a particular a series of instructions which we call algorithm. And that is what formula is about in mathematics. Thank you.